No, we'll get everything working.
Yeah, I guess.
This
Yeah.
one.
Okay, it's working. Thanks. Anil, Karen, thank you so much for being here with us today. As most of you here would probably know, Anil and Karen have both written brilliant books on AI, tackling it from different angles, but allowing the reader to look under the hood of artificial intelligence in different ways. Uh, so these days, when we say AI, what we're actually referring to is generative AI. But artificial intelligence is, of course, a lot more than that, and it's a lot older than that, though it feels like it's just, been upon us in the last couple of years. So I thought we could start with Anil telling us a little bit about, how generative AI is different from the broader superset of AI, which will set the context for our conversation.
Sure. I think I'll try to start with a little bit of history to avoid making this sound like a math lesson. So you're right, the idea of artificial intelligence goes back a long way. In fact, the term itself was coined in 1955 by John McCarthy, who was a mathematician at Dartmouth. And that year, he, along with three other people, Claude Shannon, Nathaniel, I forget his last name, and then Marvin Minsky. These four people basically decided that they're going to organize a meeting to design machines or to think about designing machines that will use language, will form abstractions and concepts, and be able to reason and solve problems like humans, all the while improving themselves. So in a sense, artificial intelligence refers to very broadly that idea, right? And it's, it has remained in spirit that particular notion of machines that we want them to do these things. But generative AI is just one small part of that thing. When we think of artificial intelligence, there were two very broad categories that were in vogue for a long time. One was something called symbolic AI, which is the idea that we can build artificial intelligence systems that use symbols or representations to codify knowledge that is out there in the world, and use some sort of rules of logic to make inferences, make deductions, do things. And this was kind of, the whole structure was imposed top-down by taking what we knew about the world as humans and somehow imposing that on the system. And this was very popular in the 80s and 90s and suffered from two particular problems. One, it didn't learn from new experiences, so to say. And the other was it was very brittle. If you had told the system that you had to use certain set of rules that you needed to operate on the data, and if somehow you asked a question that could not be decomposed into those rules, it broke, right? So by the 90s, we realized that this effort was going nowhere. But simultaneously, from the 50s onwards, there was a separate track that was also functioning, which was called machine learning. And that fundamentally is this idea that machines should be able to look at data, and there are patterns inherent in the data, and they should learn about these patterns and then use whatever they have learned to do something. And that do something part is what distinguishes generative AI from another form of machine learning, which would be discriminative AI. So when most people would be very familiar with things like face recognition, voice recognition, those are all what are called discriminative tasks, where like if I'm given a bunch of images of cats and dogs, what the discriminative machine learning AI will do is it will learn about what patterns constitute dogs and what patterns constitute cats. And then once it's learned that, then when you give it a new image and ask it to say, oh, is this a cat or a dog? It'll say, okay, this matches a dog or this matches a cat. So it's discriminating between different types of data. So much of what came about 5 years and before that was discriminative AI. So all of that stuff was for image recognition, voice recognition. But then once a machine has learned about patterns that exist in data, you can also ask it to generate new data that looks like the data that you trained it on. So if you had images of cats and dogs, you can ask it, okay, once you've figured out what patterns constitute dogs and cats, can you now produce an image that looks like another cat? May not be exactly the cat that was there in the training data, but something that's very similar. So that's what generative AI is. It essentially learns about statistical patterns that exist in the data that you have provided it, and that data could be, images, audio, language, doesn't matter what data it is. There are statistical patterns that are hidden in the data. It'll learn those patterns and then be able to generate new data that kind of resembles that. So that's generative AI, and so that's the overarching sort of field.
Thank you. Especially because right before this, Anil was saying that he wishes he had a whiteboard to explain it properly, but this was great. Karen, I'm going to take a leap forward to AGI. Why is it so nebulous? I mean, and despite which there's so much hype around it, how would you define it? What do companies see it as?
Yeah, AGI, or artificial general intelligence, is typically defined as a theoretical AI system that will have parity with human capabilities over a wide variety of tasks. And the challenge with this term is that we don't actually really have good ways of measuring human capabilities or understanding human intelligence. That's part of the reason why Anil was talking about in the history of AI development, there have been all of these different ways of trying to achieve the ultimate task of developing AI is actually, all of it is rooted in philosophical differences about, are we smart because we know things? Are we smart because we can learn things? Are we smart because we can do math problems? Or are we smart because we can read? You know, there's just like a very wide spread of different understandings of why we have this seemingly special characteristic that makes us superior to other species. And so in the context of corporations, AGI has largely been a marketing term because there isn't actually any scientific consensus around where they are actually headed. So in that vacuum of consensus, they can just define AGI as wherever they need to go. And so OpenAI is famous for this in that they've used many different definitions of AGI over the last decade of their existence. Sam Altman, when he's talking with consumers and wants you to buy the product, he's like, AGI is going to be this magical digital assistant that will do anything that you want. When he's talking with the US government to try and ward off regulation, he says AGI is going to cure cancer and solve climate change. When he's talking with Microsoft to strike a deal, the information reported that AGI is defined as a system that will generate $100 billion of revenue. And
wow.
When he is, and on OpenAI's website, the official definition is highly autonomous systems that outperform humans in most economically valuable work. So that is a labor automating definition, or they're trying to automate away the labor that people get paid the most for. So these are like 4 completely different definitions that really demonstrate the way that OpenAI and all of the other companies maneuver and select cherry pick the definition of AGI that is most convenient for the particular purpose that they are trying to achieve in that moment.
And like you're saying, it's not just a definition, it's also created a lot of hype around it, right? I mean, they hype whatever definition at that particular point they want to hype. And I mean, it's not just them. Yesterday we had Masayoshi Son of SoftBank saying AI will win the next Nobel and that we'll be like goldfish. Elon Musk saying you won't have to work in the next 10 to 20 years. So I want to ask.
Can I add something to that?
Sure.
I think I completely agree with Karen that these are shifting goalposts. From the perspective of us as average people trying to understand what it might be without getting lost in terms of what these companies are saying, there is another way to think about this. Like when we think about a chess playing AI that is only good at chess, or a Go playing AI that is only good at Go, those are what are called narrow intelligences. They're very good at one thing. And so imagine if you could create a machine learning model that was good at any possible game that you could give it, right? It could learn about any game from the data and figure out how to play the game, etc. That would be a slightly more general form of game playing intelligence. Humans have this ability where we can learn about something, how to do one particular task, create abstractions, create abstract ways of thinking about that problem, and then apply those abstractions to a completely different domain, right? From a purely technical perspective, that's what these general intelligence researchers are after. Some algorithm that allows them to figure out that, okay, I am solving one particular task and I can abstract out my knowledge about how to solve that task and then use what I have learned to solve a completely different task. That would be the general intelligence, but we're nowhere there yet, right? So keep that in mind while also paying full attention to what Karen is saying, that companies are always trying to redefine whatever it means to benefit their purposes.
Yeah, and I think a major problem, as you've written in your book, is OpenAI wants to be an everything machine, right? That's what they're looking at. So, I mean, both your books are very recent, but even within that time period, what would you say is just purely hype and what is real?
Karen, do you want?
Yeah, maybe I'll start where Anil left off, which is that there has long been in the AI discipline this notion of wanting to pursue some more generalized intelligence, because that is what humans have. We are able to learn how to drive in Bangalore and then know suddenly how to drive in San Francisco, even though these are like very different streets and very different.
If you can drive in Bangalore, you can drive in San Francisco.
Yeah, exactly. Maybe not the other way around. but one thing that I would add is that originally AI started as a scientific discipline, and it was driven by scientific curiosity of, can machines think? Can we actually get computational infrastructure to act as biological or neurological infrastructure? But what we've seen happen in the last decade plus is the huge infusion of large amounts of capital into this pursuit, and a lot of ideological drives that are motivating this pursuit as well. And so now, I think for me, there's a much more fundamental question of, should we actually be trying to create so-called everything machines or generalized intelligence when there's now this huge political and ideological apparatus and capital apparatus that is trying to pump it towards things that we actually do not want to see, like large-scale job automation, the consolidation of enormous amounts of power, the return of what I call the empires of AI, and a return back to a much more hierarchical global order rather than a more democratic and inclusive one. And to me, like, the scientific curiosity, which was a really nice philosophical pursuit, the thinking about, oh, can we actually, understand more about our intelligence by trying to recreate this? We now have to set aside those interesting questions and recognize that those questions are now being codified by a political economic order that is driving the pursuit of AGI towards a very, very dark consequences. And so for me, actually, one of the things that I really advocate for is that we should not, in fact, be building AGI or trying to pursue building AGI. We should be focused, actually, on narrow intelligence. Because one of the challenges there's many challenges for why I think we shouldn't focus on AGI. For example, when companies say that they're building an everything machine and they tell consumers, we have made this everything machine, or we are on the trajectory of creating this everything machine, and you can do anything you want with it, and it will solve any of your problems. What happens is, then people will start using it in all these different ways that the machine is not actually designed for. And from the company's perspective, they cannot make a technology like this safe, because they cannot anticipate all of the different ways that this technology will be abused, because they have communicated to the public that there is an infinite surface area of things that you can do with this technology. Whereas if you have narrow AI systems, the benefit is that you have these systems that are well scoped so that you can build, test, and deploy them in very well scoped problems. And you can then, as a company developing this technology, anticipate all of the different ways that this technology should or should not be used, and then shore up the problems of its potential abuses in advance and make the technology safer when it's diffused across the public.
Anil, do you want to add to that? And also, how do you see the development of the field in India? I mean, are there things that give you concern? I'd like Karen also to come in later about the direction that India should take, based on what you've seen in the US.
Maybe the India direction we can come back to later, but I do see a essential conflict between what might be happening in companies versus just human curiosity. Like, one of the things that keeps getting pointed out by people who don't think AI has done much is to keep saying something like, oh, AIs don't demonstrate creativity and curiosity, and we value that in humans. If we value that in humans, we are also not going to be able to stop this essential, curious, almost everything that we have done in science and technology has come out of human curiosity of wanting to find out. So I see a tension between that, which is playing out in labs around the world, in not just companies. I mean, this, like we said, this effort at developing machine learning goes back to the 1940s and 50s, and it has been an incremental effort from then on. And the companies have only just about gotten into the act, right? This has really been an academic endeavor for a long, long time. So while I agree with Karen that we should be paying attention to building AIs that are actually useful for society, and that building completely general intelligences whose use we cannot anticipate and cannot control, that would be a big problem. But simultaneously in this narrative, there's also this tension that people keep saying that these AIs are no good, and yet we are afraid of them. So that doesn't, to me, sit well. Like, either we accept that we are building something that is powerful and that has some of these abilities that we keep saying that they don't, or we ignore them because they obviously are not as good as humans. So I think, I don't know how this is going to play out. I don't think anyone knows how this is going to play out. So caution probably is warranted, right? But how we stop humans from I mean, like, fundamentally, this is an effort also. This began not as a effort to build artificial intelligence, but as a way to reverse engineer ourselves, right? A lot of AI effort is also about trying to understand the brain. And I don't know how we're going to stop that. Who are we, who's going to legislate whom? So this is playing out at such a high speed right now that I am just like watching it and feeling like this is kind of careening out of control at this point. I don't know how you feel, but
Are you watching an anxiety of panic?
I wear both hats. I feel like part of me is anxious, but part of me is just amazed at what is happening, right? And we are witnessing something quite dramatic that is taking place. So there is the part of me that loves science, that can watch this and say, oh my God, this is just another step in the evolutionary history of humans. And then there's a socially concerned part that is watching all this with, anxiety is a small word for that. Like,
I guess more panic.
Yeah.
But Karen, just to take off from that whole how it's developing question, right? Because your book is also so much about how Sam Altman, the way he is running OpenAI, has contributed to this whole race. And just the other day we saw him declare code red because of Google's release. So do you feel that maybe if he wasn't running OpenAI, this whole race could have perhaps, the fact that it's become a race in itself, to what extent is that attributable to OpenAI or just Silicon Valley culture, so to speak?
I think it's a little bit of both, because Altman is a product of Silicon Valley, and so there's a lot of different things that he did in making OpenAI happen that were really just what any entrepreneur in the Valley would have done in terms of positioning, assuming that building AI is like a zero-sum game, aiming for monopoly. That was one thing that he learned from Peter Thiel, one of his major mentors, that he also passed down to all of the other founders that he was training up through Y Combinator, one of the, of course, most prestigious accelerators in SF. But at the same time, I think there were unique things about him that allowed OpenAI to survive in under pretty remarkable conditions, I would say. So OpenAI is not a financially viable business. HSBC and other analysts recently were saying that it is a money-losing machine that will continue to lose tens of billions, hundreds of billions of dollars for years to come. Altman is singular in his ability to fundraise when there is no viable business model. And this was something that his other mentor, Paul Graham, identified very early on when he was starting off as a founder of another company before he started OpenAI that was ultimately a failure. Paul Graham said, typically you need to show results in order to get people to believe you, but unless you're Sam Altman. And so from that perspective, I think Altman was singular in getting OpenAI to where it is today, and launching the race in this very aggressive, money-fueled dynamic. At the same time, I do not think that if we were to now swap Altman out for someone else, that it would solve the problems that I articulate in my book about the power consolidation that's happening, the sheer amount of capital that's just being, burned effectively for an unknowable destination. And the reason is because now there is a power structure that has been constructed where OpenAI and all of these other companies with tech leaders at their helm are able to make decisions as a tiny group of people with a very narrow representation of the world among their worldviews. They're able to make 60 decisions in an hour that affect billions of people around the world. And that's not actually going to change anymore if Altman is fired again and another person steps in. And so to me, a lot of the problems that I see with OpenAI and with the AI industry and the way that it's operating now need to be solved at the root cause, which is the way in which these companies are currently operating as empires, as extractive and exploitive entities that are accruing an enormous amount of economic and political power through the dispossession of the majority. And we need to figure out ways to challenge that power consolidation with regulation, with bottoms-up pushback and protest from the public, and actually start unwinding some of the ways that these companies are able to exert such profound influence with just a tip of their, a tip of their finger on the scales.
Just talking about how extractive the whole industry is, I mean, in India, we've seen a bunch of announcements recently about huge data centers that are coming up. There's Google had a big bang announcement, but it's not just Google, there are a bunch of others as well. So based, the reporting that you've done where you've gone to different communities who've been affected by that, how do you see those, developments in India playing out? What should we be concerned about? Because right now there's just this whole sense of optimism. I think people even think about the jobs that data centers are going to generate, but what's the other side like?
Yeah, so maybe first to take a step back before we get to the India context, just to build on the definition of AI that Anil laid out, that there's these two different branches, machine learning and symbolic AI. But within the machine learning branch, there's also a range of different types of models. And really what we've seen in the last few years is that we went from small machine learning models to absolutely massive scale machine learning models, most colloquially now known as large language models like ChatGPT. This scale is unlike anything that we've seen in history. And basically from GPT-2 to GPT-4, just with OpenAI's technologies, they increased the amount of data that they were using to train these models by 10,000 times, more than 10,000 times, and then they increased the amount of computational infrastructure being used to train these models by more than 10,000 times. And so if you imagine what that means just from a physical hardware perspective, in the past, machine learning models were being trained on maybe a single computer chip or even a fractional computer chip. I was speaking with some researchers in India who were talking about how in a university, they share computer chips with one another, one single computer chip shared by many PhDs to do research. So in the past, it was one computer chip, maybe single digits. Multiply that by 10,000 times. Now we're talking about a single model being trained by tens of thousands or hundreds of thousands of computer chips. So it goes from a laptop training a model to massive supercomputers training one model. And what we've seen with OpenAI leading the charge is this huge infusion of capital into building as many data centers and supercomputers around the world as possible. The industry is trying to lay down these facilities as quickly as governments and communities are allowing them to lay them down. And so India has become a prime target for Silicon Valley companies because right now, if you look at the global distribution of data centers, the US has the most data centers, and Virginia, as a state in particular, has 15% of the world's data centers. They have run out of land, energy, and water in the US for supporting more of this infrastructure. So you see these companies now scouting out these resources in the rest of the world. That's why they've been striking lots of deals in the Middle East, for example. They've been trying to go into Latin America, which I talk about pretty extensively in my book. And now they're trying to bring enormous amounts of capital into India to also build this infrastructure. The problem is that even as they are trying to move away from the US to the rest of the world to find places for situating this computational infrastructure, there are a few places in the world that can actually ecologically support the size and scale of the infrastructure they're talking about. One of the challenges is energy. In order to even deliver the amount of energy that is needed for these supercomputers is a open technical question. Like we do not, like the people within the company, within OpenAI, while I was reporting my book, were telling me they have not yet invented the means to deliver the amount of energy to a single point that is required for what they anticipate to be the next generation of supercomputers they want to build. And in Meta and OpenAI's case, there has been reporting that has shown that those drafted plans for future supercomputers, they want to build facilities that will be the size of nearly Manhattan and that will use the power draw of New York City. And so this is what we're talking about, like 5 to 6 gigawatts of power being drawn by a single consortium of buildings placed in somewhere in the world. And the second issue with these facilities is not just energy, but fresh water. So when you build these facilities, you're basically, like just the way that your laptop overheats and you have to like let it rest and cool, these facilities overheat like 1,000, 10,000, 100,000 times more than your laptop. And so they use all of these different mechanisms like air conditioning and water cooling and all of these ways to try and make sure that the data center doesn't overheat and then crap out and lead to downtime, which is a #1 no-no within like data center infrastructure. Most of the water that is used to cool these facilities is fresh water, because that is, or actually even drinking water, because that is the degree of cleanliness that they need the water to be in order to not lead to corrosion of the equipment or to bacterial growth. And these facilities are ending up in regions in the world that are already water scarce. And this is like I was reading about India's circumstances right now. India is one of the most water scarce countries in the world. 18% of the population, 4% of the water resources. And so the facilities that these companies are planning to build in this country are going into extremely stressed areas already, where communities are already dealing with multiple intersecting issues around getting access to the clean water, as well as getting access to clean air, because the energy problem is being solved not just by renewables, but by fossil fuels. And in Mumbai, there was a recent investigation from a colleague of mine at the Pulitzer Center, Sushmita, who found that in Mumbai, there are 2 coal plants, one owned by Tata, one owned by Adani, that were supposed to be retired and are explicitly not being retired because of the energy demands that these 2 companies now anticipate from data centers. And so she did this amazing investigation that looked at how, there are many, many studies that link air pollution from coal plants to things like higher rates of cancer in those regions. And now those coal plants are being extended for the very purpose of supporting these large, massive scale, large language models that ultimately are like, the scale is not actually necessary. And yet we are pressuring our ecology, or we're pressuring public health in order to somehow build this thing that we don't actually need those resources to build.
I still have a bunch of questions left, but we're running out of time, and I'm sure there are a lot of people who want to ask Anil and Karen questions.
Can we have the mic, please?
And if we can keep it short, we can get as many questions in as possible.
Hi. So do you think AI can really solve problem what AI is actually creating? Like maybe energy problem and like...
That would be great, right?
I think that's one of the things that they would like you to believe. I don't see how that is going to happen that easily. But one of the marketing tools of these large AI companies is that one day we will create AI models that will help us solve climate change. I don't think climate change is a problem that AI is going to solve. So the short answer is no.
One of the problems is that these companies engage in a lot of wordplay because there are many different types of AI, and there are certain types of AI that can help with the climate mitigation problem, but then they are building like a totally different form of AI. And sometimes I use the analogy that they're like selling the benefits of bicycles while building rockets. And there's this organization called Climate Change AI. It's an amazing nonprofit that was co-founded by a researcher, Priya, who's from Bangalore. And they have done the work of actually cataloging all the different types of AI techniques for tackling something like climate change and like the energy crisis. None of them have anything to do with large-scale language models. These are narrow AI systems that are meant to tackle things like optimizing supply chains, optimizing the energy portfolio of a building, increasing the renewable energy utilization in a grid. Like those are small but targeted points of leverage where specialized AI systems can be deployed, but these are also systems that can be trained on like a powerful laptop, not on these massive supercomputers. So all of the investment right now is going into AI systems that are being sold to us as things that will solve all these problems, but they're actually actively taking resources away from the very types of AI systems that are actually going to help us gain traction on these issues.
Hi, my name is Sanchit. So my question is there a way to assign strict liability to any AI system from a legal personhood perspective?
I think that, I mean, the answer is yes. Like if lawmakers designed a framework, a liability framework to assign liability to a company that developed the system, for example, I think that would clarify a lot of things about what happens when an AI system harms an individual. And one of the challenges right now is that we don't have that liability framework in a lot of parts of the world.
Yeah, I think the technology is changing much faster than the capability of organizations and governments to keep up in terms of coming up with legal frameworks and governance frameworks. This is a very strange time to be watching all this unfold, because I don't think people really, especially people in the governance and all the lawmaking bodies, actually understand the technologies that are coming up. And like Karen said, it shouldn't be too difficult to actually put these frameworks in place, but that implies understanding what these systems are, and I don't think we are there yet.
Hi. So how is AI changing the way we speak, think, and even visualize ourselves? So it's already happening. The art that we see seems to be very similar. The words that we use have the same cadence, whether it's from companies, people, newspapers, the infamous M dash, or it's not this but this. And what's going to be the long-term impact in the way we live like this?
I think this will come down to each one of us individually, honestly. Like, I remember somebody asking me as a writer, will you ever use AI to write? And my answer to that is no, because writing for me is what gives me meaning, and I have chosen to be a writer instead of something else because it's the act of writing that gives my life meaning, and to give up that to an AI would make no sense to me. But at the same time, I'm terrible at drawing, and I have no hassles asking ChatGemini to do a drawing for me, right? And if an artist looked at what I was doing in terms of drawing, they would be aghast, because they would say, "Why are you using AI to do some drawings?" So I think individually we'll have to figure out what is it that gives our lives meaning, what craft and what art we pursue, and hopefully we won't let AIs co-opt that. And I don't know how else to say this. It really is each one of us and our responsibilities that is going to keep this whole thing at bay. If we're going to take shortcuts, then we're in trouble.
How do both of you use Gen AI, in fact?
I don't.
I use it for learning. Like if I want to learn, I mean, honestly, like for instance, if there's some esoteric matrix mathematics that I need to learn, instead of figuring out what textbooks to go find, the current LLMs are amazing educational resources. So knowing precisely what information you want to get out of it, for me that has been an amazing tool. Maybe one thing to talk about just briefly to this question of scale came up quite a bit. The capabilities that we see today in large language models are a consequence of the scale. So GPT-2 could not have done. GPT-2 and GPT-4 and Claude and Gemini, they are identical in terms of how they are architected on a very coarse-grained view of it. The only thing that has changed is the scale, how big they are and how much data they've been trained on, and that has led to the emergence, quote-unquote emergence of behavioral properties that were not there in smaller models. So all of this quote-unquote intelligence that we are seeing right now is a consequence of scale. So there is kind of a scientific / technological drive to keep getting bigger, which is also contributing to what has been going on.
I will challenge that a little bit.
Please.
In that what we've seen has thus far been assigned to scale because that is the path that we took to get there. And yet we are seeing many other research efforts now demonstrate that you can get to the same place without that scale. DeepSeek was an example of this. DeepSeek, as a model coming out of a Chinese company, was able to achieve the same capabilities as closed source models from OpenAI and Anthropic with significantly less scale. There was also this effort called Bloom, which was an open source effort to develop a large language model using only curated data sets rather than scraped data sets from the internet. And there's been not just this research, but much other research that has shown that if you curate your data set and you make sure that it's clean, you can actually get away with significantly less data to achieve the same things, because when you're scraping the internet, what happens is you end up taking in a lot of junk data, very poor quality data, that is actually degrading your model. And in order to shield the model's learning process from that degradation, you end up having to play a volume game. But if you start with clean data from the beginning, you actually can get away with much more efficient data sets that achieve efficient learning. So yeah, so there has been, and this is actually.
So we're getting into this is a great debate. So DeepSeek, I am absolutely in awe of what DeepSeek has done, right? But DeepSeek is not a small model. That's a 670 billion parameter model. GPT-2 was 1.7 billion. GPT-3 was 170. So
but GPT-4 was 1.8 trillion.
We don't know what the GPT. You might know from the insider information, yes. So, but the point is, DeepSeek does not count as a small model. Yes, they had enormous efficiencies that they brought in, but fundamentally, it is a large model. In order to run that, you still need giant data centers. It's by no means an efficient. It's efficient relative to what GPT-4 might be, but it is still a gigantic model. And even the Chinese models are getting bigger and bigger and bigger, right? So, but they have been bringing in amazing sort of optimizations, but they are optimizations on top of all the existing architecture of what these models are. And I also agree with Karen about the quality of the data. But remember, from the perspective of the research agendas, even in order to know that you need curated data, you have to, think of these as, I'm not saying that all these things are happening for the good, but these are all kind of experiments playing out in real time in front of us. In order to curate data already requires enormous amounts of computation. That is not a trivial task. It's actually computationally probably simpler to just scrape data. So when we are weighing what is required in terms of the data, there are so many other factors that come in. Curating data is not a simple task, right? And so I don't know how to weigh all these things. The overall thing is, regardless of whether you're creating clean data or optimizing big models, you are still consuming resources. And the whole question, which goes back to something Karen said earlier, do we need this in the first place? I think we should be asking that, and that's a valid question to pose. Should we be focusing on narrow intelligences?
I feel we're only getting started at this point, but unfortunately we've run completely out of time. But thank you so much, both of you. I enjoyed the conversation so much. I hope all of you did too. And
thank you so much, everyone,
they
for coming.
both have, as I said, wonderful books out and panels tomorrow as well, so you can catch them there.
And thank you, Indu, for moderating.
My absolute pleasure.
Thank you for being